Today is Wednesday, April 25th. We are going to do a lesson review of slope, and we will also talk about horizontal and vertical lines as you did yesterday, and we will add in parallel and perpendicular lines today. For your warm-up, please simplify the fraction. Please pause the video, allow students to solve these problems, and please take attendance. For the first one, 6 halves, we can simply divide 6 divided by 2. We will get 3. 8 28ths, we can divide both by 4. 8 divided by 4 is 2. 28 divided by 4 is 7. For number 3, we can divide both by 5. 10 divided by 5 is 2. 25 divided by 5 is also 5. For number 4, we can divide both by 2. We will leave these in improper fraction form because we are dealing with slope. Number 5, we can divide both of these by 3 to get our answer of 2/3. And number 6, we can then divide both of them by 4 and get 4/3. Please hand out the homework slips at this time. When the homework slips are handed out, I want students to do number 10, number 12, and number 24. For number 10 and 12, I want them to write the 3 points that they used. Make sure they are in coordinate form like 1, 2. So for 10 and 12, please write the 3 coordinates that they used. And for 24, please answer A and B. Please pause the video, allow students to fill out the homework form and turn it into the basket. Here are the answers to Monday's homework. Please check your answers for your graphs and know that there are 3 points used in this one right there, in this one right there, and we have 3 also here. Your points may be different than mine. Please check your answers to these problems now. Please keep questions over this homework until tomorrow when I will return and we'll be able to answer those. Our essential question for today will continue our lesson on slope. How can you use the slope of a line to describe the line? Yesterday in our lessons with the computers, we determined the slope of lines. Slope is labeled m and is a ratio of the change in y, the rise, to the change in x, the run, between any 2 points x1, y1, and x2, y2. Again, we can find the slope by taking the rise over the run. We can take the change in y over the change in x, or we can take y2 minus y1 divided by x2 minus x1. Remember, either of these can be x2, y2, or x1, y1. A positive slope, the line rises from left to right. A negative slope falls from left to right. Please pause the video and allow students to find the slope of these 3 lines. Remember, use y2 minus y1 over x2 minus x1. Please pause the video now. The answers for the slopes are found on the examples. In number 1, we have 3 minus 2 over negative 2 minus 3. The top is 1, the bottom is negative 5. Thus, it is a negative slope. In number 2, we have 1 minus negative 1 over 2 minus negative 4. 1 minus negative 1 is 2. 2 minus negative 4 is 6. When we simplify it, we get 1/3. In number 3, we have 1 minus negative 4, which is 5. We have negative 3 minus negative 5, which is 2. Our slope is 5/2. Notice we leave them as improper fractions when dealing with slope. In our lesson yesterday dealing with the computers, we talked about the slope of a horizontal line. We know that we can still take y2 minus y1 over x2 minus x1, and when we substitute in points, we get 5 minus 5, 6 minus negative 1. The top answer is 0, the bottom answer is 7, so our slope of a horizontal line is 0. Likewise, from yesterday's example, on our computers, we learned that vertical lines have slope as well. When we take y2 minus y1 over x2 minus x1 on this one, we get 6 minus 2 over 4 minus 4. Notice when we subtract on the top, we get 4. Divided by 0, anything divided by 0 is undefined. Our answer is undefined because it is a vertical line. Please pause the video at this point and have students try to find the slope of these 4 problems. Pause the video now. The answer to number 4 is 0 because we take negative 2 minus negative 2. That gives us 0 on the top. 7 minus 1 is 6. 0 over 6 is 0. In this one, the y's are also the same. Therefore, we know that 0 will be on the top as well. In 6 and 7, we see that the x terms are the same. Since we are subtracting x terms, we will get 0 on the bottom, thus our answer is undefined. Exactly the same in number 7. Both x terms are the same. We know it is undefined as well. How do you know the slope of every horizontal line is 0? Because the change in y is 0. What about the second one? How do you know the slope of every vertical line is undefined? Because the change in x is 0. The points on a table lie on a line. How can you find the slope of a line from a table? What is the slope? With this, we can choose any 2 points and find the slope. In this example, they used 1 and 8 and 4 and 6. When we do those, we still take y2 minus y1 over x2 minus x1. In this example, we get 6 minus 8 over 4 minus 1. That leaves us with negative 2 over 3, or negative 2/3. Therefore, our slope is negative 2/3. We could have chosen any of the points. 10 and 2 and 8 and 1 would have given us the same slope as well. Please use these points in the table to find the slope of a line. Have some people try to use the first 2, have some people try to do the last 2, and have other people try to do the first and last. Please pause the video to allow students to try to find the slope. In the first one, I chose y2 as 5 minus y1 as 2. That gives me the 3. X1 is 3, x2, is 3, and x1 is 1. 3 over 2 is our slope. We would get the same thing either way. When we simplify this, 11 minus 2 is 9. 7 minus 1 is 6. 9 over 6 simplifies to 3/2. In the second one, doing the same thing, our slope is negative 2. We are now going to talk about parallel lines and slopes. Lines in the same plane that do not intersect are parallel lines. Non-vertical parallel lines have the same slope. All vertical lines are parallel. Non-vertical parallel lines have the same slope. These are non-vertical. Vertical would be this way, up and down. So if I have 2 vertical lines, one at 2 and one at 4, we know that those are parallel due to our definition. On this slide, we have three lines, the blue one, the red one, and the green one. Which two do you believe are parallel? Please pause the video and allow students to have about 30 seconds to discuss which two they think are parallel. One of the ways that we need to be able to find out if they are parallel is to find the slope of each line. I am going to first do the blue line, y2 minus y1 over x2 minus x1. You can see I have substituted in negative 2 minus 2, negative 4 minus negative 3, and when we solve that, we get negative 4 over negative 1, or a slope of 4. Notice that it is going positively. The red line, using the same formula and substituting in negative 2 minus 3, 0 minus 1, gives us an answer of negative 5 over negative 1, or 5. We now know that blue and red are not parallel because they have different slopes. When we do the green one, using the same formula, we substitute in negative 3 minus 1 and 3 minus 4. When I do those, I get negative 4 over negative 1, or 4. Therefore, the slopes of the blue and green lines are both 4, and the red line is 5. Therefore, our green and blue happen to be parallel because they have the same slope. Parallel lines always have the same slope. On this slide, perpendicular lines and slope. Lines in the same plane that intersect at right angles, like this, are perpendicular lines. Two non-vertical lines are perpendicular when their product of their slope is negative 1. Vertical lines are perpendicular to horizontal lines. So, for example, if I have a vertical line at 0 and a horizontal line at 0, they are perpendicular because they form right angles. You will see on the next slide what I am talking about with perpendicular.